Assalamualaikum warahmatullahi wabarakatuh and good evening. My name is Rosie Taida binti Azmin. I am first year master student from Faculty of Electrical and Electronics Engineering Technology, University Malaysia Pahang. Today I will be presenting my paper titled Food Pressure Monitoring Device based on optical fiber. This is my paper abstract. A comparison between different types of device for food pressure monitoring is presented, including capacity sensor, inductive sensor, resistive sensor, piezo-based sensor, crack-based sensor, and fiber optic. From the comparison, a multi-point pressure sensor using optical fiber sensor based on microbending technique is identified as an alternative method proposed for this application. One difficulty in designing food pressure monitoring sensor is to identify the location to place the sensor on the food surface for different food size. The sensing method can be implemented to place the sensor according to the food size for effective food pressure data collection. The sensor is yet to be applied on a real human's food for food pressure distribution data at current stage. In this paper, I did a comparison on current sensor for food pressure application that have been developed past researchers. This is the content that I will cover in my presentation. Now we will go through the introduction. Do you know that based on National Heart and Morbidity Survey (NHMS) in 2019, 50.1% of adults in Malaysia is either overweight or obese, where 30.4% were overweight and 90.7% is obese. Particularly high among women, contribute 54.7%, and those aged 55 until 59 contribute 60.9%. Based on National Heart and Morbidity Survey in 2019 also said 29.8% of children aged 5 until 17 were overweight or obese. Overweight has a significant contribution to foot pain. Persons with excessive weight will experience a huge foot pressure during movement. Now we are go through for problem statement. What is the limitation of current technologies related to foot pressure measurement? The first problem statement is device versus foot size. Device suitability issue for different foot size. The second one is range of data collection. The data taken is limited to the measurement period in hospital or clinic. The third one is sensor implementation. Foot pressure measurement needs to be carried out in specific hospital or clinic. Moving on to the objective. The aims of the research are to investigate the range of foot pressure devices available in the market and within research article in heart monitoring application. The second one is to design an optical fiber-based foot pressure sensor which can continuously monitor the foot pressure during daily activities. And then the third one is to carry out laboratory and field tests for the proposed sensor and obtain the sensor performance specification. In this slide, I will compare several types of sensors designed developed for foot pressure application that have been done from previous researchers. There are 6 types of sensors that have been used for foot pressure. There are capacitor sensor, use wireless Bluetooth. The second one is resistive sensor, use complex wire. The third one is piezo-resistive and piezoelectric sensor, use wireless Bluetooth. Next, inductive sensor, use wireless Bluetooth for communication. Crack-based sensor and fiber optic sensor use complex wire for communication. What are the limitations of currently available foot pressure device? There are 6 types of sensor that have been done used by previous researchers. The first one is capacity sensor. For measurement approach, they use two electrical conductive plates based on the changing in the distance between the two plates and result in voltage vibration. And then the second one is resistive sensor, use polymer conductive based on the resistance of the material declines with the increment of the applied pressure magnitude. The third one is piezoresistive and piezoelectric. Use piezoelectric circuit based on the piezoelectric effect and the variation of an applied pressure are converted into electrical charge. Next, inductive sensor use based on eddy current principle using sensing coil and a conductor. Next, crack-based sensor based on the resistance rise, allowing pressure to be detected as a change in resistance. And last one is fiber optic sensor. Use fiber bright grating based on light reflection of particular wavelength of incident light. Now we are moving to my project methodology. In this slide, we will discuss about flowchart of the proposed optical fiber foot pressure system. Starting with foot pressure, by using my microband fiber sensor, or we also call microbanding technique, by using optical fiber act as a sensor to detect abnormal pressure. Then the data of the foot pressure will be sent using wireless data transmission to data storage. This is schematic diagram for microband sensor. In this slide, I will show the complete schematic diagram for foot pressure system. We supply some voltage to power supply to light up the LED as a input, and the light from LED we go through fiber optic, and we use the photodetector to detect output result. The result will be sent using microcontroller to computer or mobile phone. And now we are moving to proposed design. The critical locations for foot pressure measurement need to be identified prior to measurement. Fixing multiple sensors onto a saw or shoe insole is not that simple, considering different foot shapes and size. Optical fiber sensor can be placed on the foot planar as the light transmission, and measurement can be implemented using small diameter plastic fiber cable. And last one is conclusion. Foot pressure measurement system have been investigated using different approaches, including platform-based system, wearable shoes, insole system, or textile sensor embedded in socks. Second one, wearable system is preferable for this application due to usage flexibility and its suitability for outdoor foot measurement. However, the sensor selection for the pressure measurement of the foot planar is critical due to the limited space to attach the sensor on the foot surface. And the last one is, this paper proposed a wearable optical fiber sensor via microbanding optical fiber technique to detect the foot pressure based on intrinsic measurement. The accuracy, sensitivity, and the resolution will be discussed in the future publication related to this work. Okay, that's all from me. Thank you.